Right, for this video, we are continuing with exercise 5.4 on question 7. Here we have a position of one part of a curve shown in the graphic design. This is our graphic design. And okay, so this is the graphic design. It is made out of a curve, straight line, circles, straight lines again, a curve and another straight line. So apparently, one part of this curve found in here can be located on a Cartesian plane, meaning our x and y axis, and represented as points x and y. And this curve that we need to identify has an equation of y equals to 10 times of x plus 1 times x minus 3. So this table below is for this particular equation. So as always, they want us to find the values of p and q. So these are the two unknowns. All we need to do is to substitute the corresponding values of x into the equation. So right now I will copy down the equation. Y equals to 10 times x plus 1, x minus 3. Since I am looking for the value of p, the y value that is known as p, so I replace this with p, and it is going to be, just copy them down. Instead of writing x, we are going to write down the corresponding value of x over here, which is 0.5 plus 1 multiplied by, again I see x, I'm going to replace it, I'm going to substitute it with 0.5 and minus 3. So here we have the value of p. After you key into your calculator, it is negative 37.5. We do the same for q. Okay, so now q is equal to 10 times of x. Now instead of writing x, we are going to write 2 plus 1, then multiply by 2 minus 3. This gives us a value of negative 30. So here we get our marks required. So q has a value of negative 30, p has a value of negative 37.5. On the grid, draw this graph. They give you a range. Now x is from negative 1 to 3, and they want you to use 2 centimeters to represent 1 unit on the horizontal x-axis. Compare this to the previous question when they wanted 1 cm to 1 second. So right here it is 2 cm to 1 unit. So each of this box over here, each of these squares, they have a length of 1 cm. Okay, so over here, when we have 2 cm, that will be 1 unit horizontally. That is our x-axis. And on the vertical axis, that is our y-axis, we need 1 cm to 5 units. Alright, so 1 cm representing 5 units. So this is our y-axis. For every 1 cm, it represents 5 units. So you go 5, 10, 15. Whereas on horizontal, it will be 1, 2, 3. So in the space below, draw your x. Before we draw it, let's take a closer look at our x and y values. Okay, so x is from negative 1 to 3, but our y values, most of them, they are negative numbers. Within the range of negative 1 to 3, our y values are all negative, except for at x equals to negative 1 and 3. So that tells us that our graph largely will lie below the x-axis. So here I've just drawn my x and y axis, and I have to follow the scale carefully. 2 cm represents 1 unit on the horizontal x-axis. So 2 cm to 1 unit, another 2 cm. They only want us to draw from negative 1 to 3. So anything that is excess can be removed. So I don't need that part. This is my x-axis. Now let's move on to the vertical axis. 5 cm 5 units for 1 cm. Okay, so here this will be 5. This will be 10. So we go down, negative 5, negative 10, negative 15. Let's take a look at our table of values again. What is the smallest value of y? Okay, we see that the smallest value of y is negative 40. So let's just go one more step further to include negative 45. And now plot in the points. The first point that we have, block negative 1, level 0. Mark that out with an X, with a cross. Now X value is now negative 0.5. Where is negative 0.5? Has to be in the middle. Over here. And since I'm indicating the values every 1 cm, let's do the same over here. This will be 0.5. After 1, it will be 1.5. This will be 2.5. So when X is negative 0.5, we've got a Y value of negative 17.5. Negative 17.5 is right in the middle of negative 15 and negative 20. Next value we have X equals to 0, Y equals to negative 30. When X equals to 0.5, Y is equals to negative 37.5. Negative 37.5 is right in the middle of negative 35 and negative 40. So when X is equal to 1, Y has a value of negative 40. Then when instead of the X value of 1.5, look, there isn't a 1.5 over here, they jump to X equals to 2. So we have to follow when X equals to 2, the Y value is negative 30. Next, when X is equal to 3, Y value is 0. So we have to join up these points now. Okay, we have completed the graph. So remember to label it y equals to 10 times of x plus 1 multiplied by x minus 3. So in the next part, part C, point out the parts of the graphic design that could be formed by this graph. So this is a parabola opening upwards. We see that if we were to extend it, it keeps going up and up. It's like a smiley face. It's a smiley shape. And that will correspond to this portion of the graph. So highlight that. And that is our answer for part C. I will now remove all the distractions. Okay, so label it clearly that this is the answer for part C. Before we end this, I want you to take a look at all the different parabolas that have been covered in exercise 5.4. Look at all their shapes. You see over here, parabola opening upwards, parabola opening upwards, parabola opening downwards, parabola opening upwards, parabola opening downwards again, opening upwards. Which part of the equation causes the parabola to either open up or down? See if you can find the relationship. Okay, and the clue over here is to stare closely at the coefficient of x squared, meaning the number in front of the x squared. In this case, the number in front of the x squared is positive 1. It is a positive value and it results in a parabola opening upwards. It is like a smiley face. Okay, let's move on. In the next example, the coefficient, the number in front of x squared is again positive 1. It's a positive value, so I have a parabola opening up like a smiley face. Here, the number in front of the x squared is negative 1. So negative sad face. The number in front of the x square is positive 2. It's a positive. We have a happy face. The number in front of x square is negative 1. Negative for sad face. The number in front of the square term is negative 1. Sad face. The number in front of the x square, where is the x square over here? We will have to expand it out. For this equation, y equals to 10 times of x square plus x minus 3x minus 3. So we have 10x square and so on and so forth. Okay, let me just work everything out. So this is 10x square minus 2x, so minus 20x minus 30. So here we have the number in front of x squared. It is a positive 10. Since it is positive, we get a happy face.